In our lesson today, we're going to solve quadratics that give us complex roots or complex solutions. So first, just a tiny bit of a very quick review here. If we want to find the roots of this, we know that we first need to get the 15 over on the other side. And then we know we're going to complete the square on what's left. This started with 1x squared, so we're in good shape to complete the square. When it starts with 1x squared, we know the small parentheses will start with 1x. Who can tell me what needs to go in that small parentheses when I am completing the square on x squared plus 2x? Kit? So I need a plus 1, not just a 1. The plus or minus makes a difference, so always be sure we include that. So x plus 1. If I FOIL x plus 1 times x plus 1, I get x squared plus x, so plus 2x. And then last times last, I also get a plus 1, which is why we say we take that number, we put in the small parentheses and square it. Now I just changed the left side of this problem. That's not okay. If I change the left side of an equation, I have to change the other side so it stays equivalent to the original problem. So now I have x plus 1, small parentheses squared, equals 16. There's nothing out here in front except for the invisible 1. That's the way I want it. Parentheses squared equals, not something parentheses squared equals. So now I can take the square root of both sides, as long as I remember the plus or minus sign that needs to go in front there. So that means that I have square root, undid my square over here. So I have x plus 1 is plus or minus, square root of 16 is 4. So if I subtract the 1 from both sides, I get negative 1 plus 4 is 3, and negative 1 minus 4 is negative 5. Questions on that one? Yes, I could have solved it by factoring, but I wanted us to be reviewing completing the square, because when we have complex roots, we can't solve it by factoring. So continuing to review, we're talking about complex roots of quadratic equations. So we've reviewed finding roots means finding the solutions. Quadratics are the ones that have an x squared in them. Complex means we're going to end up with answers that are something plus or minus something times I. Now, remind me, where does the imaginary number I come from? What was the definition of I, Daniel? Exactly. If there's a negative number inside the square root, it's not a negative square root. A negative on the outside is okay. But if we have a square root of a negative number, so the minus sign is on the inside, that's going to give us the imaginary part of this. So what's going to be happening is when we go through this process that we just reviewed up here with this one example, instead of having a positive number in there, I'm going to have a negative number where I had that 16. That sort of makes sense? So let's do our first example of these. So first thing is to get the 14 on the other side, and if it changes sides, it has to change from a positive to a negative. Grazia, then I need to complete the square. So what needs to go in my small parentheses there? Perfect, x plus 3. I take half of this plus 6. If I FOIL that out, x plus 3 times x plus 3, I get x squared plus 3x is plus 6x. Last times last is how much, everybody? Plus 9. We've been saying once we take that half, we square it, and that's what we add. Not okay, though, to just add on one side. So I have to also add it over here on the right. And now what is negative 14 plus 9, everybody? Negative 5. So then I want to check. I have parentheses squared equals. There's nothing out here in front. It's not a minus parentheses squared. It's not a 3 times the parentheses squared. It's just parentheses squared equals. That means I'm ready to take the square root of both sides. If I had something else out in front, I'd have to divide both sides by that before I could go on. But in this case, we're good. So parentheses squared equals, so we take the square root on that side. We take the square root of the whole right side, including the minus sign, and then we put a plus or minus out in front. So that means my square root undid my square here. So I just have x plus 3 is plus or minus. Now, what do I do when I have a square root of -5? Kaylee? I make it a square root of the same positive number, and then I put an I after the whole thing. So square root of +5 times I. Final step, subtract the 3 on both sides. Final answer is -3 plus or minus √5i. Is my I last where it belongs? So I can just circle that, and there's my answer. So give me a thumbs up or thumbs down or in between. How do you feel about that example? Question. Because when you complete the square, x plus 3 times x plus 3 is not x squared plus 6. When we FOIL that out, last times last gives us that 9. All right, one more. And there are a couple of things that are wrong with this before I can start. Who can tell me things that I need to fix before I can start completing the square? Pascal? The x, not necessarily. Madeline? So the order is off. I need my x squared first and then my x. And do I do this with 5x squared minus x? What else do I need to fix, Melissa? Right, I've got to start with a 1x squared. So if I just switch them, I'm starting with a 5x squared. So I need to divide everything by 5 and switch the order on those first two. So that means I am looking at 1x squared minus 1/5 x equals -3/5. Everybody good so far? Austin, we good? Everybody good? All right, so now I need my small parentheses. It started with 1x squared now, so I'm good. So I know my little parentheses starts with a 1x. How do I get my number that goes in here? Who can help me get that number for completing the square? Charlene? We're going to take half of -1/5, which since it's a fraction, it's much easier to think of multiplying it. So I have -1/10 in there. Now I need to make this line up above it be what I would really have if I FOILed x minus 1/10 times x minus 1/10. If I did that, I'd have x squared minus 1/10 x minus 1/10 x, or 2/10 x, or minus 1/5 x. And then I'd have last times last, -1/10 times -1/10 would be plus 1/100. We don't have to think through all those FOILing steps because we have observed that all we have to do is take whatever this is that we put in the small parentheses, square that, and that's what we add up above. But I can't just add it on the left. I have to, if I add it on the left, I have to also add it on the right. So I have -3/5 plus 1/100. To add fractions, what do we have to have? Everybody. Common denominator. So I need to multiply 5 by 20 to get 100. So I also multiply the -3 by 20. So it looks to me like I have -60/100 plus 1/100. So do we think that gives us -59/100? Right, so then We now are at the step where we have parentheses squared. Nothing's in front of the parentheses, so we simply need to take the square root to undo the square and get just x minus a tenth. And if we take the square root on that side, we need to take the square root of the entire right side, including the minus sign, and we need our plus and minus in front. And we want to remember that when we are doing that, we are, well, first off, since it's a negative, what's that going to do to it? That's going to make it be an I. So it's going to be the square root of 59 over 100 times I, but the square root of a fraction is the square root of the numerator over the square root of the denominator, so just the 10. I don't want to forget my plus and minus in front there. Final step, add the 1/10 to both sides, and x is 1/10 plus or minus root 59 over 10 times I, and we just got two complex answers, two complex roots for this quadratic equation. I've got negative a tenth plus root 59 over 10I and negative and a tenth minus root 59 over 10I. It must be written like this. I must go last, and they must be separate. We're not going to write that as 1 plus or minus root 59I over 10. We're also not going to write it as plus or minus root 59 over 10 times I plus a tenth. I must go last, and they must be separate numbers. Questions from anybody? All right, then let's get some work done.